In this video, we're doing an applied optimization problem, and we've been asked to find the point on the line 2x plus y equals 3, which is closest to the point 3, 2. So first of all, we have the equation of a line 2x plus y equals 3. We want to go ahead and put that into slope-intercept form, which we can do by subtracting 2x from both sides. So if we subtract 2x from both sides, it'll leave us with only y on the left-hand side. So we'll have y is equal to negative 2x plus 3. And now this is in slope-intercept form. We can compare it to the formula y equals mx plus b, where m is the slope, so in our case negative 2 is the slope, and b is the y-intercept, so in our case 3 is the y-intercept. Now we could do this problem without graphing the line or the point, but it'll be easier for us to get a sense of what we need to do if we graph the line and the point. So let's go ahead and do that. So we have this equation y equals negative 2x plus 3. We know that the y-intercept is positive 3, so we go up to 1, 2, 3 along the y-axis, so this point right here. Then we know that the slope is negative 2, which means we're going to go down 2 and over 1 this way, down 2 and over 1. So now we have this line, which will be y equals negative 2x plus 3. Now we also have the point 3, 2. So if we graph that, we'll say 1, 2, 3, and then positive 2. So we have this point right here, and this is the point 3, 2. Now what we need to find is the point that lies on this green line here. The point has to be on this line, and we're looking for the point on this line, wherever it is, that's closest to this point here, 3, 2. And if we just look at this, we can see kind of intuitively that the point closest to this line is going to be right about in this region right here. Because if we pick a point that's, let's say, all the way out here, or we pick a point that's all the way out here, and we look at the distance between these points and the point we've been asked to find, so we look at this distance here, or for example, this distance right here, we can see that these distances are going to be much longer than the distance, let's say if this is the point that's closest to 3, 2, than the distance right here. We can see that this is obviously much shorter than either of these distances here. So intuitively, we kind of have an idea of what we're looking for, but what we know mathematically is that the closer this angle gets to 90 degrees, the shorter this distance is going to be. So what do we know about a 90-degree angle between two lines? Well, we know that those lines are perpendicular to one another if the angle between them is 90 degrees. So we need to find the equation of the line that is perpendicular to the given line that passes through the point 3, 2. So how are we going to do that? Well, remember, the slopes of perpendicular lines are negative reciprocals of one another. So the slope of our original line is negative 2. So we need to find the negative reciprocal of negative 2. Well, think of negative 2 here as negative 2 divided by 1. So if we want to take the reciprocal of this, we just flip the fraction upside down and we get 1 over negative 2. So the numerator and denominator just change places in order for us to find the reciprocal. But we need the negative reciprocal, so we have to multiply this by negative 1. And when we do, these negative signs here will cancel with one another, and we have 1/2 times 1, or just 1/2. So the negative reciprocal of negative 2 is positive 1/2. So the slope of the line that is perpendicular to the given line that passes through the point 3, 2, the slope of this line right here is going to be positive 1/2. So if we start writing the equation of that line, we can say that that line is y equals 1/2 x plus b. When we write this in slope-intercept form, y equals mx plus b, since we know that m, the slope, is 1/2. And we also know that this line passes through the point 3, 2. Well, x is 3 and y is 2, so we can plug in 3 for x and 2 for y in order to find b, and therefore get the equation of this line. So we'll go ahead and say that y is 2, so we'll say 2 equals 1/2 times 3 plus b. 2 equals 3/2 plus b. We'll subtract 3/2 from both sides, and we'll get 1/2 is equal to b. Therefore, the equation of this line, if we plug 1/2 in for b, so in for b right here, we're going to plug in 1/2. Therefore, the equation of this line, the blue line, is y equals 1/2 x plus 1/2. Now remember, what did the problem ask us to find? We're looking for the point on the original line, so a point that lies on the green line that's closest to the point 3, 2. Well, we already know that that's going to be this point of intersection right here, the point of intersection between the original green line and the line that's perpendicular to it, this blue line that's passing through the point 3, 2. So we're looking for this point right here because that's the point that lies on the green line that's going to be closest to the point 3, 2. So how do we find that point? Well, it's the point of intersection of these two lines. So to figure out where these two lines intersect one another, we just need to set them equal to each other. So what we want to do, we want to take the right-hand side of this line, the line that's perpendicular, and we say 1/2 x plus 1/2. And we want to set that equal to this negative 2x plus 3. So we're going to say equals and then negative 2x plus 3. Because these lines are equal to one another where they intersect each other, which is going to be this red point right here, the point we're interested in. So now we just need to simplify this. And in order to do that, we'll multiply through every term on both sides by 2 in order to cancel out these fractions. So we'll get x plus 1 equals negative 4x plus 6. We'll add 4x to both sides, and we'll get 5x plus 1 equals 6. We'll subtract 1 from both sides, and we'll get 5x equals 5. And dividing by 5, we can see that x is equal to 1. So remember, we're looking for the coordinate point represented by this red dot here. We already know the x value is going to be 1. To find the y value, we can plug x equals 1 into either equation. Since this point lies on both lines, it lies on y equals 1/2 x plus 1/2, and it also lies on y equals negative 2x plus 3, we can plug x equals 1 into either equation. Let's plug it into the original equation. So we'll say y equals negative 2 times 1 plus 3 when we plug 1 in for x right here. So then we get y is equal to negative 2 plus 3, or y is equal to positive 1. And that should make sense to us because if we look at our graph, and again, this graph isn't perfect, but if we just use it as a rough double check, we can see that this point is about at 1, 1, right? It's about x equals 1, and it's about y equals 1. So the point 1, 1 should make sense to us. And we can say then that the point 1, 1, the coordinate point 1, 1, is the point on this line 2x plus y equals 3 that is closest to the point 3, 2.